Alright, here is our video for 10.1, which is sums and differences of functions. Functions can be combined to form new functions by adding or subtracting the original functions. So what we're doing today again is we're just adding and subtracting original functions together. This is going to be a good review for us because these functions are all functions that we learned this year. So we're going to then take these functions and add them or subtract them. The adding looks like this. So we have h of x equals f of x plus the g of x. Or it can be written in a different way, where the x is kind of factored out and left at the back, which means f plus g of x. So these two things mean the same thing. The only thing that can get confusing here is all the different letters. So I want you to know that if there's an h, or an f, or a g, those are just different letters to make you aware that they're different functions we're talking about. So those are just names given the function. We're calling one function h, one function f, and one function g. Okay, they're just names. It doesn't matter what the letter is, as long as they're different letters, because they're different functions. The subtracting, kind of the same thing. We subtract f and g, or we can write it as f minus g of x. So here we go with example 1. We've got f of x is 2x plus 3, and g of x is x squared minus 1. We're going to find the function of h of x, which we're calling f plus g. So remember that that means we're going to take f of x, and we're going to add it to g of x. F of x in this case is 2x plus 3, and g of x is x squared minus 1. So again, if f of x is 2x plus 3, and g of x is x squared minus 1, I just add them by combining like terms. So the x squared is still by itself, the 2x go in the middle, and then the 3 and the minus 1 will give me a positive 2. So that would be our equation for h of x. Alright, so next up we're going to graph f of x, g of x, and h of x using just a table of values. So let's start with f of x here. We already said that f of x is linear, so it's going to make a straight line. So here in my table of values I have negative 2 that I'm going to plug in for x. So we have 2 times negative 2 plus 3 is negative 4 plus 3, which gives me negative 1. Okay, then I'm going to plug negative 1 in, so that 2 is going to become a 1. So we get 2 times negative 1 is negative 2 plus 3, which is going to be positive 1. Then we keep going. The next point, when I plug in 0, we have 2 times 0 plus 3, which is going to be just 3. And then I'm hoping that we can see the pattern, because if it's linear, that means it's going to be a constant rate of change, so it's going to constantly go up by the same amount. So after 3 would come 5, and after 5 would come 7. And then we can go ahead and graph this line on our grid. So f of x should look something like that. So I am going to switch colors for this next one. Let's plug in negative 2. So if I go negative 2 squared and subtract 1, we're going to get 4 subtract 1, which is 3. Then we'll try the next number out. Plug in a negative 1. So negative 1 squared is 1. When I subtract 1, I get 0. Then we plug in 0. So 0 squared minus 1 is minus 1. Plug in 1 squared, subtract 1, I get 0. And plug in 2 squared minus 1, I'm going to get 3 again. So again, we're just going to plot these values on our grid. So your g of x function should look something like that. Now we're going to move on to h of x. Now we already said h of x is also quadratic because we came up with this equation up here. So there's two options here. Either you plug all your numbers in for your equation, or we know that h of x is f of x plus g of x. So I already know the values for f and g, so I can just add them together. So minus 1 and 3 is 2. 1 and 0 is 1. 3 and negative 1 is 2. 5 and 0 is 5. And 7 and 3 is 10. So again, if h of x is f plus g, we can actually add f and g together to get h. And then we'll put them on our graph. Okay, so we'll end up with something that looks like this green graph h. Alright, the only thing left to do here is go through domain and range. Now, domain and range are going to be very important with this unit. By analyzing all the different domains, it should also be a good review for us for our final exam. So let's first of all look at this, the red graph, the linear graph. Okay, the domain of any straight line is just going to be an element of reals. The blue graph is, and you don't have to write this down, but the blue graph is a quadratic, which means it would also be an element of reals. Now, how these domains work is if the first two are element of reals, when I add them together, it's still going to be an element of reals. So what's going to happen is I'm just going to take whatever domain is common between the first two domains. So again, f of x and g of x were both an element of reals, so h of x will also be an element of reals. Now that should make sense because h of x was a quadratic function. So a quadratic goes on forever, which means it's still an element of reals. The range, you have to actually look on the graph to find. So domain, you can tell from the first two functions what your new domain will be. But your range, I have to look at the graph. So I see the smallest point on my graph right there is at 1, and all the other y values are above 1. So the range would be that y is greater than or equal to 1 for my h of x graph. So range, you have to look at the graph, but domain, you should be able to tell from the pattern of the previous ones. All right, next up we're going to try example 2, and in this one we are subtracting. We're going to take f and we're going to subtract g to get h. So h of x is going to be f of x, which is square root x minus 1, subtract g of x, which is x minus 2. When you're subtracting, please make sure you put brackets around the second function, so in this case the g of x function, and that's just because you have to remind yourself that that negative goes into both pieces. So when I put that in, we're going to get root of x minus 1, subtract x plus 2. And I know that looks kind of ugly, but that's all you can do for this question, because the root is not like terms with the other x and the 2. So I just leave it like this. There's no like terms to combine, so that's my answer. All right, so we're going to make the same kind of table that we did before. We're going to plug in these x values to get f, g, and h. Okay, let's try looking at our first point, our negative 2. Negative 2, when you plug it into the root function, is giving you a negative under the root, which is undefined. So then that means h of x will also be undefined because you can't subtract 4 from an undefined value. Undefined just means it does not exist. All right, so we did fill out the rest of the table. If you need to pause the video here, go ahead and do that. And then we're going to put on f, g, and h all onto our graphs. So I'm going to start with f in red, and I want to point this out because f has quite a few undefined values. Remember, that's because in a radical function, it can't be a negative under the root. So it starts at 1 and 0. The next point we know is at 2 and 1, at 5 then and 2, and at 10 we're at 3. So remember that radical graph looks something like that, where it has an endpoint and then it goes off to infinity. Now looking at g of x is linear. So negative 2, negative 4, negative 1, negative 3, 0, negative 2, 1, 1, 2, 0, 5 is at 3, and 10 is at 8. So when you go through, again, it should just make a nice straight line, and that would be your g of x. And finally, then let's take a look at h of x. So for h, again, it's going to be undefined, where f is undefined. So I'm just starting at the point 1 and 1. The next point is at 2 and 1, then 5 and negative 1, and 10 is at negative 5. The only thing that's a little weird about this one is remember that when we were rooting functions way back in chapter 2, there's just going to be a little part where it goes kind of up and above. So this would go above, and then it would head back down through your other points. So finally, we're going to take a look at the domain and range of h of x. Remember that the range can only be found from the graph. So when I look at the range of this, we have to guess a little bit, because I don't know exactly what this point is at the top. Like I don't know exactly what that y value is. Are we okay if I guess about 1.2? It's not quite halfway. So let's say your y's are all less than or equal to 1.2. Again, I'm guessing at that 1.2 because I don't know exactly what that is, but I know it's a little bit above 1. Now the domain, I know the domain from looking at the graph, but I also could tell the domain from looking at my other two original functions. So the domain of g of x is an element of reals, but the domain, sorry, that's g of x, yep. The domain of f of x is greater than or equal to 1. So when I compare these two domains, my new function is going to be what's common between the two domains. So what I mean by that, you guys, is that the red graph stops at 1. So my new graph, my blue graph, would also have to stop at 1 because that graph doesn't exist past there. So our domain is going to be what's common, and the common part is the greater than or equal to 1. Again, that's where my graphs would overlap. That's where it's common. There was a mistake there. That should have been an x, not a y. In our final example today, we're given two different graphs, and then we're going to take the graph of f plus g. So kind of think about this as the table of values, you guys. In the table of values, we added f and g, and then we got h. Same kind of thing here, but we have to look where the x values are the same. So I'm going to kind of look in this vertical line right here. In this line, f is at -3, and g is at 1. So if I add -3 to 1, I'll get the h value, which is here at -2. And we can do that for other points as well. For example, if I look at the line at 0, we have f, which is at 1, and g, which is at -3. So if I add 1 and -3, I get -2 again. Now let's see, are there any others? So I've got these two -2's. Let's check. Is it always going to be -2? Let's check another point. Let's check over here. We've got a 4, and I think this would hit about -6. So 4 and -6, when I add those together, I get -2. So actually, it will always be -2 just in this question. So h of x would be a horizontal line going through -2. So we're going to take a look at some of these questions then, but let's cut off 9 and 10. So we're going to look at that 1 to 7 in your textbook.